All right, so today we're going to be diving into something pretty interesting.
Oh, yeah.
It's all about abstraction in
Mm.
programming.
Okay.
You know how like you order a latte
Yeah.
at a coffee shop
Yeah.
and you don't really need to know the exact recipe
Right.
or like the barista's whole process?
Uh-huh.
That's kind of like abstraction and action,
Okay. Yeah.
simplifying things so you can just focus on what matters.
Yeah.
We're going to kind of unpack that. But like in the world of programming,
Okay.
specifically object-oriented programming,
Right.
OOP,
Yeah, yeah.
based on some of the notes you shared with me.
Great.
Um, and you'll see why this matters. And I promise, by the time we're done,
Mm.
potentially confusing terms like abstract classes and interfaces.
Oh, yeah.
Yeah, they're going to actually make sense.
Those can be confusing for sure.
Yeah.
What I find fascinating is how, like,
Yeah.
a simple concept like ordering coffee can have such a powerful parallel
Right.
in programming.
Yeah.
You hit the nail on the head. It's about focusing on what an object does, not necessarily the nitty-gritty of how it gets done.
Okay, so let's start with the basics.
Sure.
What exactly is abstraction in programming?
So it kind of mirrors that coffee shop scenario.
Okay.
Think about driving a car.
Yeah.
You don't need to be a mechanic to know how the engine works, right?
Yeah. Right.
You interact with a simplified interface,
Yeah.
like the steering wheel, the pedals, the gear stick.
Yeah.
And that's enough to get you going.
Exactly.
Abstraction in programming is similar.
Okay.
It's about hiding the complexity of the code and presenting a clean, usable interface.
So in essence,
Yeah.
you're saying that I can use a piece of code like a method
Yeah.
without needing to understand every single line of code
Yeah.
that makes it work.
Precisely.
All right.
Now, here's where it gets interesting.
Okay.
And where people often get tripped up.
Okay.
Abstraction is often confused with encapsulation.
Right.
And while both aim to simplify,
Yeah.
they do it in different ways.
Okay. I'm all ears. Break that down for me.
Think of it this way.
Okay.
If abstraction is like hiding the recipe for your latte, encapsulation is like hiding the ingredients themselves.
Okay.
You know, the latte exists,
Right.
but you don't need direct access to the beans,
Yeah.
the milk, or the espresso machine.
Gotcha.
Encapsulation protects the inner workings,
Okay.
while abstraction simplifies the interaction.
So they work together.
They do.
Okay.
Both are essential for building robust software,
Uh-huh.
and you've provided a great visual representation in your notes
Oh, right.
about how classes and subclasses fit into this.
Right. We've got classes which are kind of like
Yes.
blueprints for creating objects.
Yes.
They have attributes,
Uh-huh.
think characteristics,
Okay.
and methods, which are like actions.
And then there's subclasses,
Okay.
which inherit properties from their parent class,
Yeah.
but can have their own unique twists.
Right.
It's like how a dog inherits traits
Yeah.
from the general animal category,
Okay.
but has its own specific bark.
That's a great way to visualize it.
Yeah.
So where do abstract classes come in?
Abstract classes are where abstraction starts to take shape in the actual code.
Okay.
Imagine a blueprint that's partially filled in,
Right.
leaving some blanks for customization,
Okay.
like a semi-finished building,
Mm-hmm.
where the foundation and structure are there.
Okay.
But the interior design is up to the individual apartments.
So it's like a template,
Yeah,
providing a basic framework, but allowing for flexibility.
exactly.
You mentioned an example with an animal class in your head.
Exactly. So let's say you have an abstract class called animal.
Okay.
It might have an abstract method called speak.
Hmm.
It's abstract because no specific implementation is provided.
So it's just a concept.
It's just a concept.
Okay.
Each subclass, like dog or cat,
Yeah.
defines what speak means for them.
So a dog might bark while a
Wow.
cat might meow.
Precisely.
Mention.
But the animal class
Yeah.
could also have concrete methods like eat, which would be shared by all animals.
Right. Because fundamentally all animals eat.
Because fundamentally all animals eat.
Yeah.
Yes,
That's a really neat way to manage complexity.
it is.
Mixing shared functionality with specific implementations.
Exactly.
Okay, so now I'm curious about these interfaces.
All right.
You've even labeled them as like 100% abstraction in your notes.
Interfaces are where things get even more abstract. They're
Okay.
like pure contracts.
Okay.
They dictate the methods a class must have,
Uh-huh.
but don't specify how those methods are implemented.
Okay.
Think of a toolkit.
Right.
It provides the names and purposes of the tools,
Okay.
but doesn't tell you how to build them.
Okay.
You have the freedom to create those tools,
Yeah.
as long as they adhere to the specifications in the interface.
So interfaces are more about setting standards,
Yes.
and ensuring consistency across different parts of the code,
You got it.
even if the specific functionalities are completely different.
Imagine a universal remote control. It has an interface that allows it to interact with different devices, a TV, a DVD player, a sound system.
Right.
Even though those devices work completely differently internally,
Yeah.
that's the power of interfaces in programming.
Gotcha.
They provide that common language for different classes to interact.
That's a great analogy.
Yeah,
It's making a lot more sense now.
good.
So we have abstraction, which is the overall concept.
Yes.
Abstract classes, which are like partially finished blueprints,
Mm-hmm.
and interfaces, which are pure abstract contracts.
You got it.
Okay.
And to help you visualize this further,
Yeah.
you've included a really helpful table in your notes.
Right.
Comparing abstract classes and interfaces.
Yes, let's do that.
Okay, great.
Yeah. Okay, this table you've provided is super helpful.
Yeah.
It compares abstract classes and interfaces across like all these different aspects.
Right.
It seems like a great way to like really solidify your understanding.
Yeah.
Where should we start?
Let's tackle the definition row first.
You've already talked about how abstraction
Yeah.
is the general idea of hiding complexity
Uh-huh.
and showing only the essential features.
Right.
It's the guiding principle
Right.
behind both abstract classes and interfaces.
Right, like that coffee shop scenario.
Exactly.
I need my latte,
You need your latte.
not a lecture on how to make it.
Not the whole process.
Exactly.
Now, an abstract class
Yeah.
is like a semi-finished product.
Okay.
It can have implemented methods,
Okay.
what we call concrete methods,
Mm-hmm.
and unimplemented ones, the abstract methods.
So it's a blueprint, but some parts are still waiting for their finishing touches.
Yeah.
What about interfaces?
Interfaces are fully abstract.
Okay.
They only define what methods a class must implement
Mm-hmm.
without giving any instructions on how to actually implement them.
So pure abstraction, like we said.
Pure abstraction.
Got it. Okay, so that's the definition row.
Yeah.
Sorted out.
Right.
Let's move on to implementation.
Well, abstraction itself
Yeah.
isn't tied to any specific code.
Right.
It's a concept,
Yeah.
a way of thinking about design.
Okay.
Abstract classes can have a mix of concrete and abstract methods, so they have partial implementation.
And interfaces don't have any implementation at all.
Right.
Just the method signatures.
Exactly. They set the rules but leave the how-to part
Okay.
completely open.
Makes sense. Now, what about fields properties?
Yeah.
Classes have variables and constants.
Sure.
Where do those fit in?
Great question.
Yeah.
Abstract classes.
Yeah.
Just like regular classes can have instance variables and constants.
Okay.
Interfaces, however, can only have constants.
Okay.
And these are static and final by default,
Mm-hmm.
meaning they can't be changed.
So it's like setting ground rules. These values are non-negotiable for any class implementing this interface?
Now, let's get to a really important distinction.
Okay.
Multiple inheritance.
All right.
This is where interfaces really shine
Yeah.
in some programming languages. Yeah. Like Java, a class can only inherit from one abstract class,
Mm-hmm.
but it can implement multiple interfaces.
Okay.
This gives you immense flexibility in designing your code.
So I could have a class that's both flyable and swimmable,
You got it.
even if those interfaces are defined separately.
And that wouldn't be possible with just abstract classes.
Gotcha.
This is particularly valuable
Yeah.
in large projects
Mm-hmm.
where different teams might be working on separate modules.
Okay.
Interfaces act as the bridge,
Yeah.
ensuring these modules can work together seamlessly,
Right.
even if they're built with different technologies.
Okay. Multiple inheritance is definitely a big point in favor of interfaces.
Yeah.
What about usage?
Okay.
When do I choose one over the other?
Remember, abstraction is the overarching goal,
Mm-hmm.
making your code modular, reusable,
Right.
and easier to understand.
Okay.
Abstract classes are your go-to.
Yeah.
When you have a group of related classes with some common functionality,
Okay.
it's like a family tree. Right. The abstract class is the ancestor,
Mm-hmm.
and the subclasses are the descendants,
Okay.
inheriting some shared traits.
And interfaces are better for enforcing a contract across unrelated classes,
Exactly.
or when I need multiple inheritance.
It's like saying
Okay.
these classes might come from different parts of the code,
Yeah.
but they all need to be able to perform this action in a consistent way.
Gotcha. Now, you also have a note about creating abstract classes.
Yes.
Something about swapping public with abstract.
That's a neat trick in some programming languages.
Okay.
If you have a class declared as public,
Uh-huh.
you can change it to an abstract class,
Okay.
simply by replacing public with abstract.
Interesting.
This tells the compiler that this class is meant to be a blueprint,
Right.
not a concrete object you can create directly.
So it's like taking a finished building
Yes,
and turning it back into a set of architectural plans.
exactly.
You're focusing on the design, not a specific building anymore. You mentioned an example from the source material.
Yeah.
Something about a base zoo class.
Yes. What's that about?
Imagine you're building a system to manage a zoo.
Yeah.
You'd have different types of animals,
Yeah.
each with their unique behaviors,
Right.
but they also share common traits like eating, sleeping, and making sounds.
Uh-huh.
You could create an abstract class
Yeah.
called base zoo
Okay.
to represent this common ground.
So Base Zoo is like the blueprint for all animal types in the zoo.
Exactly.
Look.
It would define the shared methods like eat and sleep,
Mhm.
which would have a generic implementation applicable to all animals.
Okay.
Then each specific animal type, like lion or monkey,
Right.
would be a subclass of base zoo
Okay.
and would provide its own implementation for the abstract methods like make sound.
So the lion subclass would roar while the monkey subclass would chatter.
Exactly.
And they'd both inherit the eat and sleep methods
Yes.
from the Base Zoo abstract class.
Precisely this approach not only makes the code cleaner,
Yeah.
but it also prevents errors.
Okay.
If each animal had its own eat method
Uh-huh.
and there was a change to the feeding process,
Right.
you'd have to update a ton of places.
Yeah, that would be a lot of work.
With abstraction, you change it once in the base zoo class,
Okay.
and all the animals benefit.
That's much more efficient.
It is.
Okay, so this Base Zoo example
Yeah.
highlights the power of abstract classes.
Yes.
But what about real-world applications of interfaces?
Absolutely. One classic example
Yeah.
is the factory pattern.
Okay.
Let's say you're building a program
Mm-hmm.
that needs to create different types of objects,
Okay.
like different shapes for a drawing application.
Right.
Instead of hard coding the creation of each shape,
Yeah.
you can use a factory class
Okay.
that takes a shape type as input
Uh-huh.
and returns the corresponding shape object.
So the factory class acts as an interface,
Exactly.
hiding the complexity of object creation.
This makes your code more flexible and maintainable.
Okay.
You can easily add new shapes
Right.
without modifying the client code that uses the factory.
So it's more adaptable.
It is.
Okay, what about another example?
Another example is the strategy pattern,
Okay.
which lets you define a family of algorithms
Mm-hmm.
and encapsulate each one into a separate class.
Okay.
The client code can then choose the algorithm to use at runtime,
Right.
making the application more adaptable.
Wow, these patterns sound super useful.
They are.
It seems like abstraction isn't just about making code cleaner.
Right.
It's also about making it more robust and adaptable to changes.
Exactly.
I'm starting to see why you called it a superpower earlier.
It is a superpower in a way.
Yeah.
It allows you to build more complex and sophisticated systems while keeping the code manageable.
So we've covered the definitions implementation,
Yeah.
fields, properties, multiple inheritance, and usage
We
of abstract classes and
Yeah.
interface. We even dived into some real-world examples
We did.
and design patterns that utilize these concepts.
Yes.
What's next on our deep dive agenda?
Well, we've talked a lot about the what and the how.
Right.
Now it's time to address the why.
Okay.
Why should you, the listener, care about all this?
Yes, that's a great point.
How does abstraction impact the quality and maintainability of your code?
It's not just about fancy programming jargon.
Right.
This stuff has real-world implications.
Absolutely. And that's where we're heading next.
Right.
Get ready, because this
Yeah.
is where things get truly exciting.
Okay. I'm really starting to grasp how powerful abstraction can be.
Yeah.
We've talked about what it is, the different tools like abstract classes and interfaces,
Right.
even some pretty cool design patterns.
Yeah.
But why should I, as a programmer or someone interested in programming,
Yeah.
actually care about all this?
Right.
Like, what real difference does it make?
That's the million-dollar question, isn't it?
Yeah.
It's not just about writing code that works. It's about writing code that's elegant, efficient, and maintainable.
Right.
And abstraction plays a crucial role in achieving that.
All right, break it down for me. How does it actually, like, make my code better?
Well, first and foremost, it makes your code significantly easier to understand.
Right.
Think about it. When you hide all the complex implementation details behind a clean interface,
Yeah.
you're essentially creating a higher-level language.
Okay.
One that's easier for both humans and machines to read.
It's like that car analogy we keep coming back to.
Exactly.
I can drive a car perfectly fine
Right.
without knowing the intricate details of the engine.
And that simplification translates to code that's easier to read,
Okay.
debug, and maintain.
So less spaghetti code. fewer bugs, and a happier developer.
Definitely.
That sounds pretty good to me.
It does. Another major benefit is reusability.
Okay.
Abstraction allows you to create these modular components that you can use over and over again,
Right.
different parts of your code, or even in entirely different projects.
Gotcha.
It's like building with prefabricated components in construction.
Right.
You can assemble them in various ways to create a wide range of structures.
This modularity also makes your code more adaptable.
Yeah,
Right. So
absolutely.
if I need to add a new feature or change an existing one,
Yeah.
I don't have to rewrite everything from scratch.
It's like future-proofing your code.
Okay.
You can modify or extend the relevant abstractions, and those changes ripple through the system without breaking everything.
Right.
And in today's world where software needs to constantly evolve and adapt,
Right.
this is a huge advantage.
So we've got simplicity, reusability, and adaptability.
Yes.
Are there any other perks to using abstraction?
There's one more that's a bit subtle,
Yep.
but equally important.
All right.
Abstraction promotes better collaboration.
Okay. How so?
When you define clear interfaces, you're creating a shared language for everyone on the team,
Okay.
even if they're working on completely different modules.
So it's like having a common set of blueprints
Exactly.
that everyone can reference and understand,
Yes.
regardless of their specific task.
This streamlined communication makes it much easier
Okay.
to integrate everyone's work, catch potential issues early on,
Right.
and onboard new team members quickly.
Yeah. That is it.
They can grasp the high-level structure
Okay.
without getting lost in the weeds.
This is all making so much sense now.
Good.
Abstraction isn't just about writing clever code.
It's not.
It's about building systems that are robust, maintainable, and scalable.
You got it.
It's about thinking ahead and designing for the future.
You hit the nail on the head. And it's not just for complex software projects.
Right.
You can apply these principles
Yeah.
even to smaller personal projects.
Okay.
The core idea is to find the right level of abstraction for the task at hand.
You mentioned that good programmers are lazy in a good way.
Yeah.
What do you mean by that?
It's about finding ways to write code that's efficient and reusable.
Yeah.
Good programmers don't want to repeat themselves or write unnecessary code.
Right.
Abstraction helps them achieve that
Okay.
by identifying commonalities and building reusable components.
Okay, so abstraction is a powerful tool for simplifying code,
Yeah.
making it more robust, reusable, and adaptable.
Right.
It fosters better collaboration and helps us think about design in a more strategic way.
It does.
But you left us with a thought-provoking question.
I did.
How can we apply this concept to everyday tasks,
Right.
even outside of programming?
Well, think about it. We use abstraction all the time without even realizing it.
Right.
When you drive a car, you don't need to know how the engine works.
Yeah.
When you use your smartphone,
Right.
you don't need to understand the complexities of the operating system.
Sure.
When you order food online, you don't need to know the logistics of how it gets to your door.
Okay.
These are all examples of abstraction in action.
So the idea is to find ways to simplify complex processes
Exactly.
by hiding the unnecessary details
Yes.
behind a clean and intuitive interface.
And the challenge is to start applying that same thinking to other areas of your life.
How?
How can you break down a complex project
Yeah.
into smaller, more manageable tasks?
Well-
How can you create systems or checklists
Right.
to streamline repetitive processes?
Right.
How can you organize information
Yeah.
in a way that's easier to access and understand?
That's a really interesting challenge. I'm going to start looking for opportunities
Yeah.
to apply abstraction in my own life,
Good.
both in my work as a programmer and in my everyday routines.
Right.
It's like a new lens through which to view the world,
I love that.
a way to find elegance and efficiency in everything we do.
Abstraction isn't just a technical skill.
Yeah.
It's a way of thinking
Right.
that can empower us to solve problems more effectively and navigate the complexities of modern life with more clarity and ease.
This deep dive has been a revelation.
Good, I'm glad.
We've explored the nuances of abstraction in programming,
Yeah.
from abstract classes and interfaces to design patterns and real-world applications.
We did.
And we even discovered how this powerful concept can be applied
Right.
to enhance our everyday lives.
Yes.
I'm walking away feeling inspired and ready to simplify my world one abstraction at a time.
And that's what it's all about.
Yeah.
Empowering you to see the world and your code in a new light.
Thank you so much for joining us on this enlightening journey into the world of abstraction.
My pleasure.
Until next time, keep exploring, keep learning, and keep diving deep.